Okay, so we've done two examples now with real eigenvalues that are distinct and not repeating. So now our next example, we're going to move on to complex eigenvalues. And once again, that comes down to us first taking the determinant of a minus lambda I. All right, so in doing so, we're going to go through and subtract lambda off the main diagonal. And again, we're setting this determinant equal to 0. So now if we actually multiply to find this determinant, we get negative 1 minus lambda times itself, which makes it squared, plus 9 equal to 0. And we could multiply this out and apply the quadratic formula, but it's actually easier to move the 9 over to the other side and then just apply the square root property so that we end up with negative 1 minus lambda equals plus or minus 3i. If we multiply through by a negative 1, that's 1 plus lambda still equals plus or minus 3i. Then if we subtract 1 from both sides, we end up with our eigenvalues, which are going to be negative 1 plus or minus 3i. So the next thing we're going to do is now go through and find the corresponding eigenvectors. And we'll just take lambda 1 to be negative 1 plus 3i for this process. We'll show you why we just take one eigenvalue in a few minutes from now. So once again, we need to solve a minus lambda I times vector v is equal to 0 to find the eigenvector. So in this case, it's going to be our negative 1, 3, negative 1, minus the eigenvalue negative 1 plus 3i times the identity matrix. And again, we're now taking this times unknown v is equal to 0. And then when we actually subtract this, we're going to have the matrix negative 1 minus a negative 1 plus 3i in the first spot. And then we'll have a 3 in the second spot, a negative 3, and then a negative 1 minus negative 1 plus 3i down here. And again, that's still times v is equal to 0. If we now simplify this down, we end up with the negative 1s canceling out, and we just get negative 3i and a 3, a negative 3, and down here is another negative 3i. And again, that's times v is equal to the 0 vector.